Hello, everybody. Welcome to the second lesson of data visualization. Today, we want to talk about basic customization, basic Matplotlib customization. Okay, let's get started. So we are gonna import the usual libraries that we want. So import NumPy as NP, import pandas as PD, import matplotlib.pyplot as PLT. And then also if you can also import OS, and then with that, if you import OS and then you can get the directory that you have. Okay, I'm gonna minimize this. Get the directory, and then you can change the directory. So you can say os.chddir, which stands for change directory, and then set your own directory. So then if I want to, for example, read a file or write a file, I don't have to mention the whole path. I should just mention from this slash and afterward. So that's going to be like very convenient. I just do this only once. Okay, with that being said, let's get started. Basic Matplotlib customization. Setting the fixed size argument. So last session in basic data visualization lesson 1, we worked with a fixed size a little bit, but today we want to talk about that even more. The easiest way to change the size of a figure is to use the fixed size arguments. The easiest way that you can use this argument while instantiating a figure object, or you can alter the height and width of a figure. Okay, let's first set the size during initialization. Let's say x is np range 1 to 11. That being said, is x is numbers between 1 to 10. Is array of numbers 1 to 10. So remember, when you use this np range, you always have a start, stop, step, and then stop is not inclusive. Okay, and then let's assume that z equals 1 over x. So as a matter of fact, that's the reason I didn't include 0, because 1 over 0 is not defined. And then z equals x squared. And with that being said, let me, so when you're having this fixed size argument, always remember that you have to have an equal sign, and then in parentheses, you gotta pass in two numbers. The first one is the width of the figure that you want, and the second one is the height. Okay, let me run this, and then we see what's the results. And okay, here we are plotting we are having three plots together. First one, I'm just plotting x, so it's gonna be just a line. So first of all, I have fig comma x1 x2 x3, and then so I have plt subplot 3 subplot 3, and then fixed size 9 and 8. So it means that my width is 9 and my height is 8. And then x1 dot plot x, x2 dot plot y, x3 dot plot z, and then plt show. So if you do that, you get this. So here with fixed size 9 and 8, I'm telling Python that I want this figure to be 9 inch by 8 inch. 9 inches by 8 inches. Okay, sometimes maybe some people are not very comfortable using inches. They want centimeters. If you want that, Matplotlib unfortunately does not currently support the metric scale, which is funny because the only country that uses the inches is the United States. The rest of the world, they use centimeters. However, it's easy to write a function to convert between these two from, for example, centimeters to inches. All you have to do is to define a function and the name of the function, and then pass in the value, and then return value over 2.54. So the reason for this is that 1 inch is 2.54 centimeters. So if you have 10 centimeters and you want to see how many inches you have to divide 10 by 2.54, and in that way you get this. Okay, and then adjust the size of the plot by using a function to convert any values you put in into inches. For example, this would create a plot with the size of 15 centimeter by 10 centimeters. Let's run this. Here I have only one plot. So x is all the numbers between 0 and 5, 0 inclusive, 5 exclusive, increment 0.1. Y is just exponential of x, and then I want to plot x versus y. X on the horizontal axis, y on the vertical axis, obviously. And this image that we got is has 20 centimeters width and 10 centimeters height. If I want it to be 15 by 10, I can do this. So with doing this, I'm getting 15 by 10. Another example that we can have is this. X is all the numbers between 1 to 10, increments 0.1. Y is exponential of x, and z is just log of x. And then I'm gonna run this. So fixed size is 9 and 5, so 9 inches by 5 inches. And then x equals fig.add subplot 1 and 2 and 1. So remember, number of rows, number of columns, and index. So here we are gonna have 1 row, 2 columns, and then x1 is x versus y, x2 is x versus z. So if I run this, oops, let's see what the problem is. Okay, I didn't run this, I guess. Let me try it again. Yeah, as you can see, we have exponential function and log function. And then instead of the fixed size argument, we can also set the height and width of a figure as well. These can be done either via the set function with the fig height and fig width argument, or via the set fig height and fig width functions. Let's go with the second option and let's see how it exactly works. So I'm running this. It's very similar to before, but the only different thing is that I'm not using fixed size. I'm using fig.set underscore fig width fig height. Everything else is the same, and as you can see, the result is also exactly the same as before. And finally, you can also use set underscore size underscore inches of the figure object, which accepts 2 integers, the width and the height. So you do this again as before, you get exactly same result. All of them are pointing to the same thing, all of these 3 methods, and you get the same result. Perfect. Okay, next topic. Manipulating Matplotlib text. For example, titles, labels, text. Adding text to plot is a common task. These can be labels for axes, titles for plots, and similar things. Some of the common text related commands used used to add text like labels and titles to plots. For example, we are reviewing a couple of them here. I think 5 of them. plt.text or ax.text, plt.annotate or ax.annotate, plt.xlabel, plt.ylabel, or ax.set underscore xlabel, ax.set underscore ylabel, plt.title or ax.set underscore title, plt.subplot or fig.subplot. Okay, whether we'll be invoking the PLT instance or relevant access instances depends on whether we are using PyPlot API or object-oriented API. With that being said, let's see a few examples. Okay, I'm gonna have x the range of numbers between 1 to 5, increment on 0.1, 1 inclusive, 5 exclusive. As always, y is exponential of x, z is log of x, w is x squared, and t is 1 over x. And then I want to run this. I'm going to run the text first and then explain what's going on. So if you run this, and it might take a couple of seconds, but you get this. Okay. So here I'm going to run this code and then talk about it. First of all, we are defining figure as always. So figure equals plt dot figure. So you can call it figure, you can call it fig, whatever you want. But here I'm calling that this figure equals plt dot figure, fig size 8 and 5. X equals figure dot add underscore access 0011. And then here I have this new argument x dot set underscore title. So here I'm assigning a title, and we're gonna see then I have x dot plot x versus y. So x is number between 1 to 5, y is exponential of x, and then I want my x label to be our x and y label to be exp. Yes. And when I do that, and then in addition to all of that, I want to have a text embedded in my plot. So this one is a new one and tricky one. I'm using x.text, and then the position of my text, the position that my text starts is 1 and 80. So these are not percentages, yes? These are the actual locations. So 1 and 80, this is the exponential function. What I wanted my text to be. The text is, this is the exponential function \n. \n makes the rest of the line to be printed on the second line from 0 to 5, and then a comma color equals red in PLT show. If you do that, you see this is the title for X. This is the access level title, and then you see exponential x, and you see rx, and then you see this is the exponential function from 0 to 5 in red, and location is 1 and 80. Okay, With that being said, let's we have used the generic text method and supplied the positional x and y values. Keep in mind that x and y here refer to actual values on the plots, not percentages. Their positions will depend on the data you're plotting and the scale they are in. By default, Matlab creates a one by one plot. Okay, I'm talking if we didn't have any coordination with for x or something, then it's gonna be a 1. Uh, Next example is very important and comprehensive example. So this is a comprehensive example, and make sure that you understand this example very well, because this is super important to know what's going on here. Oops, sorry. So first I'm gonna just run it, and after running that example we can see what's going on. So this is the results, and now let's read it line by line and let's see what's going on. So I'm saying fig comma x plt subplots n rows to n columns to. So I'm going to have 2 rows and 2 columns. So it's going to be a 2 by 2 plot. Fig size is 9 and 6. Fig.subtitle. So this is the subtitle for the figure itself. It's not for my axis. So I have 4 different subplots, but this is for function is not axis level title, it's figure level title. So figure level title is for functions. And then I'm going to have x0 and 0, x0 and 1, x1 and 0, and x1 and 1. So top left is going to be 0 and 0. Then top right is going to be x0 and 1. Then bottom left is going to be x1 and 0, and bottom right is going to be x1 and 1. So on the top left, x0 and 0, I want to plot x versus y, and then x0 and 1, I want to plot x versus z. Bottom left, x1 and 0, I want to plot x and w, and then bottom right, I want to plot x versus t. Now for each of them, I want a title. The first one exponential, second one log, third one square, fourth one inverse. For each of them, I want a y label. So I say, for example, x in brackets 0 and 0 dot set underscore y label exponential x, expx, and then so on and so forth. Inside in each subplot, I want a text. So in the first one, I want my text to be located at 1.5 and 80, and this is exponential function from 1 to 5. Second one, I want to have this is a log function. This is log function with color green, and the position I want to be 2.5 and 0.5. So that's my position. And then I want the third function to have this is square function at the position of 1 and 20. And the fourth one I want to have this is inverse function at the position 2 and 0.8. And you run this, you get this very cool graph. Really cool. Okay. The subtitle is added at the figure level and is above all of its subplots. The title and labels can be set on the axis level, where each axis can have separate titles and labels. So each of these, this is one this is x0 and 0, x0 and 1, x1 and 0, and x1 and 1. As we just saw, each of them can have their own, let's say, y labels, they can have their own titles, but we can have figure level title as well, as we just had. The figure level title was 4 functions. Okay, I hope you enjoyed that example. Let's move on. So here x is numbers between 1 and 5, incremental of 0.1, then y, and then z. And then let me run this and see what's happening. So here I'm having something new. I'm having legend. I want to add legend. If you want to add a legend, you gotta do this. So let's read it one line at a time. Fig and x, plt dot subplots, fig size 9 and 6, x dot plot, x and y, color blue. So here I'm using only one plot. I'm not, there's just, I don't have like many subplots. So, and on it, I want to plot x and y and x and z. So both the curves I want to be on the same subplot. I want x versus y to be in blue, and I want it to have a label of exponential function. And I want x and z versus z to be at red, and I want it to have the label of square function. And then I can tell where my legend box should be. It can be upper center that I chose. This lock argument is used to specify the location of a legend, and it's fairly intuitive. A combination of upper, lower, and center with left, right, or center. We don't have center, but else we are going to have upper left. So if I change this to upper left, as you can see, the only change is that now the legend box is upper left. It can be upper left, upper right, upper center. It's going to be, yep, this is going to, and also it can be lower left, lower right, lower center, and then, yeah, okay. You can also leave it blank. So something like this, just deleting everything inside parentheses. And then if you do that, Matlab automatically chooses which one is best for you, which is top left. Okay. Adding a legend outside of access via bbox underscore to underscore anchor arguments. So sometimes you want to have your legend box outside the chart. How can we do that? It's not that hard. I'm going to run the code and then explain it. So here I'm having this. First of all, everything else is the same as before. The only thing that is different is this leg argument, and then still I have ax.legend, but rather than saying lock equals upper left, I'm having rather than that, I'm having this leg equals x.legend lock center b box underscore to underscore anchor, then 0.11 is, and the position is going to be 0.1 and 1.2. So what does that mean? So here First of all, this b box to anchor needs two arguments, and these are percentages. So it says that like the x should be for example at point 1, and then y should be at 1.2, which is 120%. Uh, so go ahead and just play with this and see what happens when you change this number. For example, you can also make it a negative number, and then let's see what happens. So when I do this, then it's gonna be at the still at the position that I determined. Again, these are percentages, and then it's gonna be 0.1 and negative 0.4. Okay, having that in mind, we are gonna move on to the next topic that we have. Changing the legend size. So you can change the legend size. How could we do that? We'll see. Let's see how we can change the legend size. Okay, let me run this and then I'm gonna explain what's going on. So here, again as before, we have fig x, fig comma x equals plt subplots, fig size 9 and 6. And then here I'm having this x dot plot, x and y color equals blue, label exp function, and then x dot plot, x and z color red, label equals square function. This is the part I want to talk about. This is the important part. Leg equals x dot legend. So here our legend is having a title. The title of the legend is plots, and then font size is going to be 12. So it's going to be font size for the legend. Then the title of the legend can have its own font size. So font size for that is going to be 16. So as you can see it here in the picture, the word plots is bigger than exp function or square function. And then I have it as b box underscore 2 underscore anchor half and -2. So again, you can play always with this and just put it different places. Yeah, you can always change this, but and you can get rid of this one. So now let's run it again. Okay, I want, let's say 0.4. I don't like this. I want it to be okay. Yeah, something like this. So the reason is that this is okay. Let me make this a little bit even, maybe 0.8. I don't know. A little bit. I want to shift it to the right. Okay. Yeah, now it's better. Okay. So and then ncol equals to, what does this mean? Ncol equals to, it makes the legend two columns. So we have column 1 and then column 2. Column 1 is exponential function, column 2 is square function, so the legend is in two lines. Okay, Moving on, changing the font size using font size. Let me run this one and see how this one works. So here I have the legend, and I'm starting with figure PLT figure fixed size 8 and 5, and then x equals figure dot add underscore access 0011. As always, I'm gonna have a title for my x exponential function. I'm gonna have x and y and x and z, x and y in blue with label exponential function, exp function, x and z in red with label square function. Then for each of them, I'm going to use font size for. So here, as you can see, I have x.setX label our x. Then font size for this is going to be 16. So you can see this is a little bit bigger than usual. And here it's bigger than exp of x, which is the y label is bigger than usual. And then legend, I want my legend to be really small. So I say font size equals 8. So with font size, you can always, whatever text you have, you can make them bigger or smaller. Okay, while we can set each font size like this, if we have many textual elements and just want a uniform general size, one good for all approach, this approach can be repetitive. In such cases, we can turn to setting the font size globally. How? With plt.rc params, and then in brackets font size equals 12. So 12 in or like 18 or whatever you want uh, in quotation marks. So if I run this, we can see what's happening. As you can see, here we are having exponential function, and we are having like these texts are really bigger, and or I can change it to other amounts. Okay. Uh, so here when I run this, as you can see, everything is in bigger sizes. And here, if you want to save your graph, you can just say fig.savefig, and then rather than passing the whole um, path, you can just mention the name of the file. And since you had this os.chdr, then you don't have to worry. Then later on, when you're looking for a folder, where did you save it? If that's your question, it's going to be the folder that you have, and then the folder that you have with the name that you have. Okay, so for example, for me, it's right here, and this is the graph. Okay, with that being said, let's keep going, and we saw how we can change the name. Okay, where were we? Here we go. Changing plot colors. You can always do this as well if you want. Change the plot color, and then you can save it as one function blue. Let's see that one. One function blue. Here, as you can see, like the round is now blue. You can also do this. Not a very important thing, I guess. But okay, Setting the axis range, you can do that with xlim and ylim. So let's, okay, what happened? Sorry. Okay, here we go. Let me run this first and then I explain. So here I want to set the axis range, and then I have xlim and ylim. So the first line, first three lines, they're exactly like always. Figure equals plt dot figure, fixed size 6 and 6. X equals figure dot add axis 0011. X dot plot x and y. Then here I'm saying set xlim from 0 to 4 and set ylim from 0 to 10. So I want to limit my x and y for sure between 0 and 4. I don't want, and not necessarily Python will use all of that. So as you can see, from 0 to 1 is empty, and then like after 3 is also empty in the x-axis. Still, when you tell this to when you have this, it's going to be only, it's going to focus on x between 0 and 4 and y between 0 and 10. So x dot set lim underscore xlim x dot set x dot set underscore xlim x dot set underscore ylim. Another example, which is a better example maybe, and a little bit with more details. Let's see that one, this one. Okay, I ran it first, and now let me explain it first. First of all, let me change this PLT RC params, because once you change it, it's gonna carry on for the rest of the code that you have. So I'm gonna change this from 18. It's like too big, and I'm not interested in that much of a big text. So I'm gonna just make it 12 here, and then rerun this. Okay, better. So what am I saying? I'm saying fig equals plt dot figure, fig size 9 and 6. Then x, so we have two objects here, x and x2. X is fig dot add subplot 1 and 2 in 1. So one row, two columns, and then index 1, index 2. Yes. So x dot set underscore title is full view, and then I'm going to talk about x. So on x dot plot, I'm going to have x and y and x and z. X and y is going to be in blue, label exponential. X and z is going to be in red, label square. Now x2, I'm going to call it truncated view. And again, these lines are going to be exactly the same. So I'm plotting x versus y and then x versus z, all of them on x2, but x2, I'm limiting myself to where x is between 2 and 3. So I don't want between 1 and 5. I want to just zoom in right here. So that's what I'm doing, zooming in between 2 and 3. So I'm going to say x2 dot set underscore xlim is between, and I pass in a list of numbers 2 and 3, and then leg1 equals x dot legend, and leg2 equals x2 dot legend, and I run everything and I get this result. Very cool result. Okay, remember, you can do this in this format. So we are doing exactly same thing, but just in different formats, using x as a list rather than just having x1 and x2. Okay, I'm going to run this. The result is going to be absolutely the same. But here, uh, yeah, it's exactly the same. But here I'm saying fig and x, PLT subplots, n rows 1, n columns, n cols 2, fixed size 9 and 6, but then I'm not going to have these two lines. So I'm saving two lines. Then I'm going to, rather than x and x1, I'm going to have x in brackets 0 and x in brackets 1. So everything is going to be absolutely the same. And I just run that. So remember, you can use, and we had this in the previous session, but you can always have x, define x1, x2, or define x as a list and then have x in brackets 0, x in brackets 1. Okay, change tick frequency. Let's see what's going on. Let's define our x, and so x is between 1 and 5, increment 0.1, y is exponential of x, z is x squared. We can set the tick frequency on a figure level and axis level. Let's change the figure level tick frequency. If we have multiple axes on it, the ticks on all of these will be uniform and will have the same frequency. So I'm running this. So first of all, what is tick? Tick, these are ticks, yes. 4.6 and this black line above it, 4.2, and this very small, you see, it's even hard to see, but the very small hard, very small vertical line, 4.2, that's tick. Yes, I want to change them. We are talking about them. So first three lines as always. Then here is where the magic happens. plt.x ticks and plt.y ticks. So for x ticks, I want a number between 1 and max of x and increment of 0.4. And then in plt.y ticks, I want between 0 and max of y and increment of 10. So if I don't have these, if I only run this, the default is going to be the tick here is the increase is in like 20. So 0, 20, 40, 60, 80, 100, 120, 140. And then here 1, 1.5, 2, 2.5, 3, 3.5. But when I include everything else, so as you can see here 1, 1.4, 1.8, 2.2, 2.6, and on the vertical axis I have 0, 1, 0, 10, 20, so far. Okay, setting axis level tick frequency. So if you have multiple plots going on, you might want to change the tick frequency on the axis level, not on the figure level. You want to do it differently for each plot. If you have multiple plots going on, you might want to change the tick frequency on the axis level. For example, you want infrequent ticks on one graph with frequent ticks on the other one. You can use the set underscore x ticks and set underscore y ticks functions on the return axis instance when adding subplots to a figure. Okay, so let's have x and y and z defined. X is numbers between 0.1 and 5, increment 0.1. Y is exponential of x and z is log of x. And having that said, having that being said, let's run this and let's see what's going on. So first of all, I'm defining fig comma x, PLT subplots, n rows 1, n cols 2. So 1 row, 2 columns, fixed size 9 and 6. 9 and 6. I'm going to have figure level title. So figure level title is two functions. In x1, I want to plot x and y, x, and then I mean on the first plot, x bracket 0, and then x bracket 1, I want to plot x versus z. So exponential function is going to be plotted on the first one, on the left panel, and logarithmic function will be plotted on the right panel. And I want to have access level titles. So exponential for the first one and log for the second one. And now this one is the new part. Here I'm setting for exponential function, the first two rows here, these are for exponential function. So x bracket 0, set x ticks and set y ticks. So x ticks is going to be between 0 and max of x plus 1. So I want to go make sure that everything is covered up to very end. And then np, maybe I can do the same here as well. So maybe I have to add, for example, 10 to it because the increment is on 10. So if I do this, I have it from 0 to 5 and I have it from 0 to 140. On the second one, for example, I want my x to have the same thing from 0 to max of x incrementing 1. However, on y label, on vertical label, I want it from, so let's say if what's going to happen if I say go from 0 to max of z. If I say that, as you can see, it's going to start from 0 to 1.2. However, that's not what I want. I want, because log of 1 is 0, but log of anything before that from 0.1 to 1 is negative. And I want them to be covered. So for that, I could say mean of z, minimum of z. Yes. If I say that, let me say that and see what's going to happen. If I say this, then I'm going to get from negative 2.303 and then negative, and increment is by 0.4. It's not very pretty to have the vertical labeled like this. So rather than saying minimum of z, I'm going to say round of minimum of z. And if I run this one, I'm going to get this cool one. Okay, and then again you can say +1 or not, whatever you want. It's up to you. It depends how far you want to go ahead, but I just prefer not to say it. Okay, rotate axis tick labels. What am I talking about? If we, for some reasons, if we want to rotate these tick labels, let's say 5 here is like very good, but there are some positions that they are not very easy to read if we have them like that. Let me start with an example. Let me run this. So first of all, we are importing datetime from datetime. So from datetime, import datetime. And then I'm saying fig and x, PLT subplots, fig size 8 and 4. So This is like my favorite way to start. Fig, comma, x, PLT subplots, and then if you tell Python how many rows and how many columns you have, then Python knows exactly. If you don't tell, the default is n rows equals 1 and columns 1. So you can, if you have only one plot, you don't have to mention that. But if you have more than that, you can say n rows equals 1, n columns equals 5, whatever. And then this is my favorite way usually to start. Fig, comma, x, plt dot subplots, and then figure size. Okay. Then here x is something called pd.dateRange. And then the first element is datetime today. So what's that? Datetime today. I'm going to just run this part. And as you can see, it gives me the year 2021, the month 10 or October, the day 11th, the time of the day. So it's 18:31 minutes. So this is hour out of 24. This is minute 31. This is second. And so it gives you very good information. So when I run this and I have periods equals 20, then the output is going to be something like this. It's a datetime index, and then I have this, and then with dot toList, I can just easily convert this to a list. So it's gonna be a list after running this. As you can see, it's a list, and then the list has like 20 elements. Each element is gonna be a timestamp. And then y is np.random.randint. So integer numbers randomly selected from range 0 to 9. So 10 is exclusive as always. How many integers? 20. So this is start, this is stop exclusive, and then this is how many we have. And then I'm plotting x versus y. So if I do this, if I plot x versus y, as you can see, it's not very easy to read. Yes, because there is an overlap on here between like different times. Because of that overlap, it's not easy to read them. And I don't like that. I don't like the way we have the ticks on the x label. So rotating x-axis ticks. As usual, there are two ways to go about rotating x-axis tick labels. Rotate them on the figure level using plt.xticks, or rotate them on the axis level by using tick.set rotation individually, or even by using x.set underscore xtick labels and xtick param. Okay, let's go ahead and do it. So we are here doing figure level, and so the only thing different is this one, plt.xticks in parentheses rotation equals 30. Here we have set the rotation of xticks to 30, indicating a 30-degree tilt counterclockwise. As you can see, they have rotated 30-degree counterclockwise. Alternatively, we have done this as well. So numbers are different, but don't worry about that. So here, because each time we do this, we have it, we are selecting random numbers. But here we are saying x dot tick underscore prompts, and then x is equals x and label rotation equals 30. So that's also possible. And then so you have some options, yes. So you can also use this one, x dot set x tables, and okay. So another format that you can use is this one. Let me run this and then explain. So here's the other format. This one is a little bit different because I'm using x.set underscore xtick labels. And for this, I had to add this strf time, because if I don't add this, when I do this, so for example, this was our x, yes, I had this, and as you can see, you have year, the month, and then the day, and then hour, and then the minutes, and then the second, and then the after that, whatever comes. But let's say I only want year, month, and day. So for that, I tell Python the format that I want. Yes, so this is you can tell the format. So if I add this one, strf, and then percentage sign y and m and d, and if I do this, then I'm gonna get only this part. Yes, and then I can also make this change it to a list. So if I change it to a list, it's going to be like that. Or so if I run this and I run the rest, okay. So if I run this, I'm going to get this. So it's still tilted 30 degree. You can also change the font size, but it includes all the days. Okay, and then rotate dates to fit automatically. This one is very easy to use. You can do that with fig.auto fmt auto format underscore x date and fig.auto fmt underscore y date, and Python automatically does that for you, formats it for you, which is very easy and convenient to use. Okay. Last example, which is I think the most one, I kept the best for the last. X, Y, Z. X is between 0.1 to 5, increment 0.1. Y is exponential function. Z is logarithm. Here I'm changing a few very important things at the same time. So I'm changing line style. Line style is simple line styles that can be defined using the strings. So line style can be solid, dotted, dash, or a dash dot. Let me run this first. If I run this, I get this. Now here I am The only thing that is important is this line, yes? Everything else is as before. Figure equals plt dot figure, and x equals figure dot add axis, and the last line plt dot show. The magic happens here. The magic happens here. This one is the important one. So here I'm saying plot x versus y. I have color. So color can be, or like later on, I'm gonna have a marker face color. So first of all, the options that we have is B for blue, R for red, G for green, B for blue, Y for yellow, W for white, K for black, C for cyan, and M for magenta. These are the options that you have. You can have different line styles. You can have dashed. You can have solid. So if I choose solid, this line rather than dashed is going to be solid. Let, let me make this a little bit less frequent. So let me make x increment by 0.2. So you get to see the line is even like, so here we go. So the line is solid right now. I can make it dots, dashed, and so this is dots. And then I can make it dashed as well. Marker. Marker right now is star, but it can be circle. So O for circle, S for squares. This sign, which sometimes we use that for power, for example, 2 to power 3. But then this sign means triangle, plus for plus, star for star. So let me change, for example, this one, the marker to circle. And as you can see, and then we have marker face color. So how the inside of these markers would be depicted, what color is going to be inside of each of these markers. So here I'm saying red. Then I can have marker size. Marker size can be like smaller or bigger. So I'm making that a little bit smaller. And then, so marker can be O, can be S for square. If I did make this S, you can see it's now square. I can make this markers a little bit bigger. And then, so the in x.plot you have control over all of these. You can also have control over something called alpha. Alpha is Matplotlib allows you to regulate the transparency of a graph plot using the alpha attribute. By default, alpha equals 1, but you can make it, for example, any number like 0.4. If I do that and I run this, it's going to be like this. So you see the change. And also you can change the line width. So let me get back alpha to, let's say, 0.8. Line width, just take a look at the width of the line right now, and then you can make it, for example, thicker. So rather than 1, I want it to be 4. And I run this, and you can see that now the line is really thick. So you get to just play with all of these options, and it gives you a big flexibility. Marker size, adjust marker size, obviously. And you can have S for square, O for circle, star or plus. So here, for example, is plus, and then the markers would be plus. When it's plus, because plus does not have inside, marker face doesn't matter anymore. but here I'm gonna have it star and then just run it. And okay, perfect. Thank you very much everybody for listening.